Hello everybody, welcome into another lesson. So today we are going to talk about the point slope form of a line, which helps us when we have 2 points on a line but we don't know the slope or anything. But the goal is to convert something from point slope form into the slope intercept form, the y equals mx plus b. So point slope form, you have y minus y1 equals m, the slope, times the quantity of x minus x1. You want to convert all that into y equals mx plus b. Then I have a reminder here for the slope formula, which is equal to y2 minus y1 over x2 minus x1. So let's get started here. Let's say we're given the points. What points? -2, -1, and what's the second point? 1, 2. Okay, so we have a line that runs through the points -2, -1, and 1, 2. We don't know anything. We don't know the slope. We don't know the y-intercept. We don't know any of that. That's okay. What we first want to do when we're given 2 points is find the slope. That's exactly what we need to do. So we'll find the slope. Of course, we have to determine which point we want to be our first point, which point we want to be our second point. I'll make 1, 2 our second point. So if we make 1, 2 our second point for the slope, that y2 is going to be 2. Minus the y1, which is that -1. So we'll have 2 minus -1 over, now we'll have x2, which would be 1, minus x1, which would be -2. So you'll have 2 minus -1 over 1 minus -2, which we know 2 minus -1 is the same as 2 plus 1. And then 1 minus -2 is the same as 1 plus 2. Okay. Well, in the numerator we have 2 plus 1, that's 3. The denominator we have 1 plus 2, that's also 3. So 3 over 3 is 1. So we got the slope being 1. The slope of this line is 1. We now know that. So next thing you're going to do is plug this into your point slope form. Okay? Well, let's start here. Again, it doesn't matter which one of these you want to designate to be your first point or your second point when you're working in point slope form. You should get the same result. It doesn't matter, but once you pick that point, you got to stick with that point. I'm going to make the 1, 2 that y1. In the x1. So we will put this into our point slope form equation. We'll have y minus y1, which we determined to be 2, equal to the slope m, which would be 1, times the quantity of x minus our x1, which we determined would be 1, which simplifies into y minus 2 is equal to, well, 1 outside of the parentheses. That just means it's the answer in parentheses. You distribute the 1, you'll just get x minus 1. Okay. Now we're almost to where we need to be. We just want to get y by itself. Well, we have y minus 2. We need to add plus 2 in order to get rid of the minus 2. So you have y minus 2 plus 2 is equal to x minus 1 plus 2, because you got to do it to the other side. Alright, so y minus 2 plus 2, the 2's go away, you're left with y by itself is equal to that x. -1 plus 2 is +1. So we now have an answer in slope-intercept form, y equals x plus 1. And that is exactly what we're seeking to do, is find the slope-intercept form of this line, and we've arrived at that, y equals x plus 1. And I do have more examples here. This isn't going to be it. All right. let's see, we have the point negative 4, 3, and 4, negative 1. Okay, so we want to find the slope-intercept form of an equation with a line running through the two ordered pairs negative 4, 3 and 4, negative 1. Again, first thing you want to do, find your slope. That's always the first thing you should do. Find the slope, which would be y2 minus y1 over x2 minus x1. It doesn't matter which point you pick to be your first point, which point you pick to be your second point. I'm going to pick 4, negative 1 to be my second point. So that's my second point. My y2 is negative 1. You'll have negative 1 minus your y1, which in this case would be 3, over my x2, which would be 4, minus my x1, which would be negative 4. Well, we can simplify this. We have negative 1 minus 3 in the numerator, but in the denominator we have 4 minus negative 4, which is the same as 4 plus 4, okay? Now, we can do the numerator and denominator. Negative 1 minus 3 is negative 4 in the numerator. The denominator, 4 plus 4, is 8. So I have negative 4 over 8, which will simplify down to negative 1/2. So my slope is negative 1/2. So I found the slope. Now, I need to pick a coordinate to be my x1 and y1. I'm going to say 4, negative 1. So we'll do y minus negative 1 is equal to the slope of negative 1/2 times x minus my x1, which would be 4. Well, y minus minus 1, that's y plus 1, is equal to, now I need to do the distributive property here. If I take negative 1/2 times x, I'll get negative 1/2 x. Then if I do negative 1/2 times negative 4, I'll get positive 2. So you'll get negative 1/2 x plus 2. Now we're almost to where we need to be. We want to get y by itself. Well, we have plus 1. We need to do minus 1. So y plus 1 minus 1 equals negative 1/2 x plus 2 minus 1. Well, 1 plus 1 is 0. Y is now by itself. Y equals negative 1/2 x plus that 2 minus 1. Well, that's just plus 1. So the slope-intercept form of this equation of the line is y equals negative 1/2 x plus 1. And now had I decided to put in the other one here, the other point, I would have got the exact same result for my slope-intercept form. You could pick whichever one you want. You just need to, stick with that ordered pair once you start out. But I would have got the exact same result had I done negative 4, 3 instead. So that's something to keep in mind. Okay. Well, there's that ordered pair. I got a few more. I got like 4 more, and then we'll be done for the day. All right, what points do we have next? This shouldn't be too bad. We have the points 0, 0, and negative 1, positive 1. Alright, so we want to find the slope-intercept form of the equation of the line running through 0, 0, and negative 1, positive 1. Well, first thing, you're going to do your slope. So we'll make y2 that 1, so we'll have 1 minus the 0 for the y1 over x2, which would be that negative 1, minus 0 for the x1. Well, the numerator 1 minus 0 is 1. The denominator negative 1 minus 0, that's negative 1. So your slope would just be negative 1. So we found our slope. Excuse me. Alright, so your slope is negative 1. Now, we need to find the point slope form of this equation. We'll pick one of these to be our y1. I think that's a no-brainer. We'll do y minus 0 is equal to that slope of negative 1 times our x minus 0. Well, y minus 0 is just y. We have negative 1 times x minus 0, which would just be x. Negative 1 times x is just negative x. So that's all we can do with this. Y equals negative x is our equation. Y equals negative x would be our slope-intercept form. That would be the best we can do. Y equals negative x. So there's that. Alright. 3 more. This time, let's see, we have the ordered pairs 4, 2, and what's the next ordered pair? Negative 8, negative 16. So we need to find the slope-intercept form equation of a line running through the ordered pairs 4, 2, and negative 8, negative 16. First thing you do, once again, find your slope. So we'll pick negative 16 to be our y2. So negative 16 minus that 2, which will be our y1, over that negative 8, which will be our x1, our x2, minus the 4, which will be our x1. Okay? Well, in the numerator you have negative 16 minus 2, that's negative 18, over negative 8 minus 4, well that's negative 12, which we can simplify this down to 3 halves, because they both have a common factor of 6 and the negatives cancel out, so you'll get a slope of 3 halves. That would be the simplification of that. You get 3 halves for your slope. Now, you're going to take your y, designate one of these points to be y1. I'm going to go with the 4, 2 for our first coordinate. So, that would be y minus 2 is equal to the slope of 3 halves times the quantity of x minus 4. Okay, well, let's simplify this. Y minus 2, well, let's do the distributive property. 3 halves times x is, well, 3 halves x. Minus, then we got 3 halves times 4. 3 halves times 4 is 6. Okay. At this point, we should be getting pretty good by now at dealing with fractions and canceling them out and being able to do factorizations of fractions. We should be pretty decent at this by now, so that's why I'm not going through this in gory detail. It would take too much time. By now, I assume you're comfortable with dealing with fractions. So if you do need help with that, please see my previous lessons about adding, subtracting, and multiplying and dividing fractions. But for the sake of time, we're going to assume you know how to deal with fractions. Alright, so we have y minus 2 equals 3 halves x minus 6. We have y minus 2. We want to get y by itself. We need to do y minus 2 plus 2. Make that equal to 3 halves x minus 6 plus 2. Well, minus 2 plus 2 goes to 0. Y is now by itself. The 3 halves x we can't do anything with. But negative 6 plus 2, well, that's negative 4. So your slope-intercept form of the equation is going to be y equals 3/2 x minus 4. That's exactly what you would get. Y equals 3/2 x minus 4. I got two more examples for today. What points are we given this time? We are given the points 8, 7, and negative 9, 7. Alright, so we are given the points 8, 7, and negative 9, 7. So you want to find the equation of the line. Well, again, find your slope. So the y2 will be that 7 minus the y1 of 7 over your x2 of negative 9 minus your x1 of 8. Well, in the numerator, you have 7 minus 7, that's 0, over your denominator of negative 9 minus 8, that's negative 17, which 0 over negative 17 is 0. So we have a 0 slope. So in a point slope form, pick your equation, pick which point you want to be your y1 and x1. I'm going to say 8, 7. We'll have y minus 7 is equal to that slope of 0 times x minus 8. Well, the right side, 0 times any number is 0. So you're left with y minus 7 equals 0. Which we want to get y by itself, you got to add 7 to both sides to do that. So you have y minus 7 plus 7 equals 0 plus 7. So negative 7 plus 7 is 0. You just get y by itself. 0 plus 7 is 7. So the answer for this equation is y equals 7. You would just get a horizontal line with a 0 slope running through y equals 7. That's exactly what you would have. So it's good to see a 0 slope. I got one more example. Alright, so we have the points 5, negative 6, and 3, 2. So we want to find the slope-intercept form of the equation of a line running through the points 5, negative 6, and 3, 2. Once again, find your slope. I'll make y2 that 2. So the slope will be equal to 2 minus the y1 of negative 6 over the x2, which will be 3 minus the x1 of 5. Which would mean in the numerator 2 minus negative 6, that'd be the same as 2 plus 6 over 3 minus 5. Which means in the numerator 2 plus 6 is 8. The denominator, you have 3 minus 5 is negative 2. 8 divided by negative 2, well, that's negative 4. So we now have a slope of negative 4. We found the slope, negative 4. Now we need to find, let's determine which point we want to be our y1 and x1. I'm going to say 3, 2. That looks easier to deal with. So we'll have y minus 2 is equal to that slope of negative 4 times x minus the x1, which was 3. So now we have the equation in point slope form. You have y minus 2 equals negative 4 times the quantity of x minus 3. Well, we have y minus 2 equal on the right side. Let's do the distributive property. Negative 4 times x, that's negative 4x. Then you do negative 4 times negative 3, you'll get a positive 12. So you have y minus 2 equals negative 4x plus 12. Okay, What we want to do now is get the y by itself so we can put this equation in slope-intercept form. If you have minus 2, you need to do a plus 2. So you have y minus 2 plus 2 equals negative 4x plus 12 plus 2. Well, negative 2 plus 2 goes to 0. You just got y by itself, which you'll have on the right side, negative 4x, excuse me, plus 12 plus 2. 12 plus 2, that's 14. So we now have the slope-intercept form of the equation where you have y equals negative 4x plus 14. That would be our answer, negative 4x plus 14. So if you're ever just given 2 points on a line, first thing you want to do is find the slope. Always find your slope. Then pick which one of these points you want to be your x1, y1. It doesn't matter which one you pick. You should always get the same result every time. So you put in those values into the point-slope form equation. You do your distributive properties and your other basic math, and you should get it into slope-intercept form. That's the goal, is to get this into slope-intercept form. So really there isn't much to point-slope form. It's a little bit harder than what we did yesterday, but if you know how to find the slope and substitute values in for x1 and y1, you're good. That's really all there is to it. And if you remember the distributive property, and sometimes dealing with a little bit of fractions, you should be good. So that's been it for the unit of writing equations of lines and dealing with the coordinate plane, at least for now. The next lesson is going to be solving equations with variables on each side of the equation. So both sides of the equation will have variables on it. We're going to break down how to solve those in the next lesson. So I hope everybody has a good day. Take care.